Do you feel the vibes?
Right? So how do we tackle something like sine of 50, right? Is like, it's not a special angle, but is there no hope for it? Well, some of them, you can combine them with special angles, and like a combination of two special angles would give you another angle, and you can, find the trig values of that. So let's take a look at this one. We're going to have sum and difference identities, okay? So for example, if you have, sine of A plus B, right? Sine of A plus B. So for example, if you have, sine of 30 plus 45, those are both special angles. Now, when you add them, there is also a way to do that, okay? So these are the identities. So we know we use the letter, a Greek letter for angle. We can also use the equivalent of A and B in Greek, right? So here we go. Sine of A plus B, right? If you have sine of A plus B. So look at the pattern. It's sine, cosine, cosine, sine, right? That's the pattern. Sine, cosine, cosine, sine. So this we're going to memorize. Sine, cosine, cosine, sine. And now look at this. I have A, B, 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 right? So I have AB, AB, AB. Sine, cosine, cosine, sine. And then it's AB, AB, AB. Now, let's talk about, are we adding or subtracting? So look, if I am adding, so a concise in math, when you have two formulas, and the only way they are different is with their signs, you can actually combine them into one. You can like merge them into one. So look at the plus. It's written on top. This is not plus or minus. The plus is written on top. So throughout the formula, you look for the sign that is on the top. So if it's sine A plus B, then here it'll be plus. Okay? And then if it's sine A minus B, here it'll be minus. So sine, cosine, cosine, sine, AB, 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 AB. If it's plus, it's plus. If it's minus, it's minus. Now let's take a look at the cosine. The cosine too, look, you've got A, B, B in the same order, okay? Now look at this. This is different. It's cosine, cosine, sine, sine. Cosine, cosine, sine, sine. Plus this time switches to minus. Minus goes to plus. Okay? So this is the formulas. And then for tangent, it's a little bit different. It's again tangent A plus tangent B, 1 minus tangent A, tangent B. So let's follow the plus version. Plus is on top, plus is on top, minus is on top. So that's how it would go. Okay? So people like sing these two to the tune of, so it's like sine, cosine, cosine, sine, cosine, cosine, sine, sine. I don't know why that helps in like memorizing, but like that's the thing, right? That's the pattern we need to know. Yes? Correct. Like the alphabet. It's aleph and beit, like in Hebrew. Yep, exactly. Okay, so to write to use sum and difference identities, you have to rewrite the angle as a sum and difference, as a sum or difference of angles found on the unit circle. Nothing. So it just means if you have a minus first, then you follow in the formula all of the lower symbols. Let's do a couple and you'll see how we're going to follow them, okay? All right, so why don't we take a look at this one, sine of 15. 15 is not one of the special angles. However, it's a combination, right? It's sine of 15 is 45 minus 30, right? No, you are definitely allowed to have a negative angle. Here, right? It's sum and difference. You can have A plus B or A minus B. Okay? Yeah. So sine of 45 minus 30. It's positive 45 minus positive 30. Okay? So now, 45 and 30 are angles on a unit circle. And that's how we can do this. So this is now a difference, right? So we're going to use the difference formula here. So sine of 45 minus 30, right, is going to be, so it's sine, so it's going to be sine, cosine, cosine, sine. Sine of the first, cosine of the second. It's minus, so it's going to be minus, then cosine, sine. So look, right? Same pattern, okay? Sine, cosine, cosine, sine, 45, 30, 45, 30, 45, 30. And just like in the formula, right? The minus is the lower symbol. You go with the lower symbol, minus, minus. Okay, so now I know exactly how to do these. Sine of 45, root 2 over 2. Cosine of 30, 1/2, minus cosine of 45, root 2 over 2. Sine of, cosine of 30 was root 3 over 2. And then sine of 30 is 1/2. So now, here, I get root 6 over 4 minus root 2 over 4. Combine them over 4, root 6 minus root 2. Right? So that is exactly what you should get. Okay? That's how we leave it. Okay, now here, this is cosine of negative 15. There are actually two ways of doing this, right? One way is the following. Cosine of negative 15, this is the same as, so how do we get negative 15? You could do like 30 minus 45, right? That gives you negative 15, right? Or, okay, cosine of negative 15, right? Look at what we used in the first lesson. What happens if you have cosine of a negative angle? Negative goes away. So cosine of a negative angle is just cosine of the same angle. So cosine of negative 15 is just the same as cosine of 15. We can apply that identity first, then everything else. So for instance, if instead I had sine of negative 15, remember with the sine, the negative comes out. This would be negative sine of 15, and then I would just continue with that. Okay, so why don't we use this here? So this is now going to equal cosine of 15. All right, cosine of 15, right, is 45 minus 30. What else could it be? 60 minus 45. Why don't we do that this time? Cosine of 60 minus 45. It really doesn't make a difference at all which one you use. It's literally, it's your preference. Yeah. It's your preference. It'll be the same exact thing. So here now this one is cosine. So it's going to be cosine, cosine, sine, sine. Cosine, cosine. And it's plus sine, sine. Keep the angles the same, 60, 45, 60, 45. Because look at the cosine. If it's a plus, then it's a minus. Because 60 minus 45 is one way to get 15. So we did 60 minus 45. That's correct. So cosine of 60 is 1/2. Cosine of 45, root 2 over 2. Plus, if cosine of 60 was 1/2, then sine of 60 is root 3 over 2. Sine of 45 is root 2 over 2. So here I get root 2 over 4 plus root 6 over 4, root 2 plus root 6 all over 4. And you're going to see that you're pretty much going to get the same values in different combinations, okay? A lot of root 6s, a lot of root 2s, a lot of 4s. Okay, now, sine of 75. How could we do sine of 75? 60 and, well, so 15 isn't a special angle. 45 and 30, or 30 and 45. So this is sine of 45 plus 30. The order does not matter. So now if it's sine, it's going to be sine, cosine, cosine, sine. So sine, cosine, plus or minus, plus cosine, sine. Make sure you keep the order of the angles consistent. Okay, so sine of 45, root 2 over 2, cosine of 30, root 3 over 2, cosine of 45, sine of 30. So here, we're going to get root 6 over 4, root 2 over 4, root 6 plus root 2 over 4. Okay? All right. Next one, cosine of 105, right? You're going to do that one on your own, right? I'm going to give you 45 seconds. We're going to race. On your mark, get set, go. No, if it's being added, it doesn't matter if it's root 2 plus root 6. Okay. What is the pattern going to be for this one? Cosine, cosine, sine, sine. Are we going to have plus or minus in the middle? Minus in the middle. So what angles did we pick? 60 and 45. What else could we have done? There's nothing else we could have done? That would be 70. How about 135? Could you use 135? And 30. 135 minus 30, that's also 105. You could also do that. Okay? So then, right, cosine, cosine, sine, sine, we get root 2 minus root 6 over 4. So remember, the plus changes into a minus. And then all, still, so remember at the 60, that's the bigger angle. So the x-coordinate is less 1/2. The y-coordinate is more root 3 over 2. Okay, now, the next ones, yeah. Root 2 minus, root 6 minus root 2 over 4 does not work. It doesn't work. No, but if you did it the other way, you can. If you do it correctly, you would still get the same thing. Okay? Let me do the rest and maybe I can do this one again with those. Okay, so now what if you have a radian angle, right? What if you have something like, something like 5 pi over 12, right? So take a look here. First, for the radian angle, rewrite the angle as 2 separate fractions with the same denominator. So something over 12 plus something over 12. Then find numerators that add or subtract to the numerator you want, which will reduce to a special angle. Okay? So let's take a look here then. So this one is going to be sine of something pi over 12 plus something pi over 12. Now I need to get 2 numbers that add to 11. but reduced to a special angle. Now, you have to go like methodically for this, right? Don't just go like haphazard, weird order. I like to go like, I start with 1 and 10. If I put 1 and 10 in here, does 1 pi over 12 reduce to a special angle? No. So 2 and 9, does that reduce? 2 and 9, it'll be pi over 6 and 3 pi over 4. Yeah, that works. So that's one thing that works. 2 and 9. Are there any others? How about 3 and 8? Yeah, right? How about 4 and 5? No, not 4 and 5, sorry. So 3 and 8, 4 and 7, it doesn't work, right? 5 and 6, it doesn't work, right? So not everything that adds to 11 will work. Okay, so let's do this one. Sine of pi over 6 plus 3 pi over 4. Okay, so sine, cosine, plus cosine, sine. Sine of pi over 6 is a half. Cosine 3 pi over 4, root 2 over 2, root 3 over 2, root 2 over 2. So look, if for sine of an angle we got 1/2, the cosine of the same angle is going to be the other one, root 3 over 2, right? So now this is going to be something over 4 plus something over 4, all over 4, root 2 plus root 6 over 4. You can definitely combine those steps. Okay? All right, this one. Cosine. Okay, so what works here? What's one thing that works? 1 and 6, does that work? No, because 1 over 12, pi over 12 is not. So what else? 2 and 5 doesn't work. 3 and 4 definitely works. So cosine of pi over 4 plus pi over 3. Okay? All right. We're racing. Ready? Ready, mark, get set, go. Okay. Okay. Fabulous. So one thing I'm seeing, right, is cosine pi over 3 is a half. Sine pi over 3 is the root 3 over 2. If you mix that up, then you get root 6 minus root 2 over 4. Okay? Which is not correct. Okay. Now, if you go back to the first lesson that we did, right? If you go back to the first lesson here, we learned all of these identities. One of the ones that we learned were these cofunction identities. Sine of pi over 2 minus theta is cosine, right? Another way to write that is sine of 90 minus theta is cosine theta, right? So if somebody told you that, you're like, okay, no way, there is no way that's true, right? Show me that's true, right? Another way to say that is verify that that's true, right? So then you're like, okay, let me show you. So let's do that now. Here, we are going to verify the identities. The fact that this is an identity already means it's a true statement. One thing equals another, right? Because in all identities, one side equals another. We're just verifying, meaning we are showing that it is in fact true, right? We know it's true. We're just showing that it is. When we do these, the way we do them is we just work on one side, leave the other side as it is, work on one side until we get something exactly identical to the other side, right? So in fact, what we also like to do is keep that equal sign aligned the whole time. So here I have sine of 90 minus theta. Well, this is a sum and difference identity, right? This is sine, so it's sine, cosine, cosine, sine. So sine, cosine, minus cosine, sine. We're going to align with that equal sign, right? Sine, cosine, cosine, sine. Now, so far we haven't done anything other than what we've been doing all day today. Now, what's sine of 90? What's sine at 90? 1. So this is 1. So this is 1 times cosine of theta. Minus, what's cosine of 90? 0. 0 times sine of theta. 1 times cosine is cosine, minus 0. Well, that's just cosine of theta. And look, that does equal to the other side. Okay, so that was the goal. The goal was to just work on the left side and make it look identical to the right side. So let's do this other one. Cosine of 90 plus theta. All right, so let's see. So this is cosine, cosine, minus sine, sine, equal to. What's cosine of 90? What's cosine of 90? 0. So 0 minus, what's sine of 90? 1 times sine of theta. This is 0 minus sine of theta. Negative sine theta does in fact equal negative sine theta, so these are congruent to each other. Okay? Correct, because if you have 0 minus 3 times x, this is just negative 3x. Okay, so now, next one. Okay, let's do another race. On your mark, get set, go. Oh boy. Oh. Okay. Right? Yes? You should get the other side. If you don't get the other side, then we have done something wrong, right? Because if you're proving an identity, again, you're proving something that is already true. I mean, you're not proving it, you're just showing that it is true. Okay. All right. Ready for the last one? On your marks. Get set, go. Okay. Right? Okay. Awesome. Okay. All right. Now we can take some questions. Any questions? First, any questions on these 4? Any questions on any of the other stuff we did today? Sine of pi, 0. Cosine of pi. Wait, did you say sine of pi or cosine? So sine of pi is 0 because pi is here and the y value there is 0. All right, so that's it for this lesson, but let's
Press start.